Okay, so for number 11, we have that the set X contains the integers from 1 till 20, and we want to give an example each of the following. So for item A, we want a family A of subsets of X such that the intersection contains the element 1 and the union contains all the elements of X. So what we're going to do is we're going to say, we're going to let A be the family of sets, and each of them are going to be the sets A sub I, where we're taking the index coming from the set X. And the reason that we want to do this is because we want to do A sub 1 has the element 1, A sub 2 has the element 2, and so on, because when we do the union, we're going to have every single element from 1 to 20. And each A sub I is going to have two elements. It's going to have the element 1 and it's going to have the element I. So to give some example, A sub 1 is just going to have the element 1, right? Because whenever it's repeated, we just count it once. A sub 2 is going to have the element 1, 2. A sub 3 is going to have the element 1, 3, and so on until A sub 20, which will have the element 1, 20. So from here, we can see that the intersection, the one thing that they're all going to have in common is going to be the set containing the element 1. However, the union, if we join all of these, we're going to have 1, 2, 3, and so on until 20. So the union is just going to be the set X itself. So that's it for item A. For item B, we want the family B of 4 pairwise disjoint subsets of X, such that the union of these subsets, the union is going to be equal to X. So let's remember what we mean by pairwise disjoint. So, for example, these two here are not pairwise disjoint because they have one element in common. So every single subset has to be disjoint. So the way that we're going to do this is we're going to break it down into 4. So maybe we can see that the first one is going to be 1, contain 1, 2, 3, 4, 5. That's the first subset. The second subset is going to contain 6, 7, 8, 9, 10. The third subset is going to have 11, 12, 13, 14, 15. And the fourth subset is going to have 16, 17, 18, 19, and 20. So we can see here that each of these sets in the family, they're pairwise disjoint because none of them have anything in common. And if we do the union, if we join all of it, we're going to have all the elements from 1 to 20. And lastly, for item C, we want a family of 20 pairwise disjoint subsets of X such that the union is equal to X. So it's going to be very similar to the first one. Very, very similar. The only difference is that all of them won't have the element 1 because we need them to all be pairwise disjoint. That is, we need them to have nothing in common. So we're going to say that the family is going to be comprised of the sets C sub I, where I belongs to X, that's capital X, and each C sub I is just going to be the set containing its index. So C sub 1 is just contains 1, C sub 2 just contains 2, and so on and so forth until we get to C sub 20, which just contains the element 20. So we can see that each set is going to be pairwise disjoint since they'll have nothing common. However, if we join all of them, we're going to have the set X because we're going to have the elements from 1 to 20. So that is it for problem 11.